Lab 25, Example 1, Part 2. In Part 2, we're going to do parts D and maybe E. So for D, it asks to graph f of x in the window, x min is equal to -2, x max is equal to 0, y min is -1, and y max is 1. And then it asks, what does this graph tell you about the multiplicity of the 0 between -1 and 0? So we're going to get out our calculator here, press on. You're going to go to y equals, and in that first slot you're going to put in your function up here, or f of x. I've already done so. You're going to go to graph. You see it has a little bit of a window here. It tells you where there's a couple of zeros, but we want to change the window specifically to these specifications. So we're going to go to the window button right here, and it says x min, so we're going to put in x min is -2. X max is 0, so I'm going to put in 0, I'm going to change that there. And then it says y min is -1 and y max is 1. Once you have it to those settings, you're going to go back to our graph button, and it's going to graph out that window. It might take a little bit. Yeah, there it goes. So, and it asks, what does this graph tell you about the multiplicity of the 0 between -1 and 2? So on this graph, this is the window from -2 to 0. 0 is on this right-hand side, and -2 is on this left-hand side. And it asks about the 0 between -1 and 0. So that's to the right-hand side of this graph. So they're talking about this part of it here. We actually have two zeros that are shown on this window. We have this one that passes through the x-axis, and we have this one that bounces off. If a 0 passes through the x-axis, we know that has odd multiplicity. If it bounces off without passing through it, we know that has even multiplicity. So the multiplicity of the 0 that goes from -1 to 0 has even multiplicity because it bounces off like that. So we can answer this. This means that it has even multiplicity. And we can actually find out what this 0 is. So to find out what this 0 actually is graphically, we can go to our calc menu, so that's second trace. You can go down to our 0 since we're looking for zeros. Press enter. And it's going to ask for our left bound. We have somewhere around here is our cursor. There's our cursor. We actually see it. So our cursor follows our graph. And it asks for a left bound, so we're going to go to the left of our 0, press enter. It asks for our right bound, so we're going to scroll the cursor to the right of our 0, press enter. And it asks for us to guess, so we're going to go close to our 0 and then press enter. And it'll think for a little bit. And it gives us our 0. It says x is equal to -0.5 and our y is 0. So in this way we can actually find out what zeros are actually part of our function up here. And if we do that, we find out that we have x is equal to -1/2 is a 0. And in fact, it's a 0 at least 2 times because that's even multiplicity. And if you went to the right-hand side of the graph, you would also find out that 7/5 was a 0 using this exact same method. And we could actually figure out what the 0 is too, but it's not quite a nice even number, so we might not use it in part E. So after we do that, we're going to go and do part E. So part E asks to determine all of the zeros of f of x and write f of x in completely factored form. And what this lab wants you to do is to do it using synthetic division. So we found out in part D that we have x is equal to 7/5 is 1 0, and we also have -1/2 is also a 0. In fact, we know that -1/2 is a 0 twice. So we're going to use synthetic division and divide these zeros out of this whole polynomial. We're going to start with 7/5. So to do that, to do synthetic division, we have 7/5 over here. Like that. So we're going to write all the coefficients of our polynomial up here. So we have 20, we have negative 8, we have negative 83, we have positive 17, we have 69, and we have 21. We're going to write another thing down here. For the first number, we're just going to bring it straight down. This is just going to be 20. What we're going to do with this number that's down here is we're going to multiply it by 7/5. 7/5 times 20 is 28, so we're going to put that here. We're going to add these two numbers together. Negative 8 plus 28 is 20. Then we're going to do the same thing here. 20 times 7/5 is 28. Negative 83 plus 28 is negative 55. Negative 55 times 7/5 is negative 77. And then again, adding 17 and negative 77, we get negative 60. Negative 60 times 7/5 is negative 84. Then adding 69 minus 84, we get negative 15. And then negative 15 times 7/5 is negative 21. And then 21 minus 21 is 0. So we have now just confirmed that 7/5 is in fact a 0 of this function up here because it ended in 0. If it ends in 0, then we know that is in fact a 0 if we do synthetic division. And any kind of division, actually. So now that we've done that, we can actually rewrite this function up here like this. So we know that f of x is equal to our 0, x minus 7/5, times our polynomial that was left right here. So we took out an x. We took out the x that was 7/5. And we have a remaining polynomial here. So this is going to be 20. And because we took out x, it's going to be x to the 4th instead of x to the 5th. So this is x to the 4th plus 20x to the 3rd minus 55x squared minus 60x and then minus 15. So we're going to continue in this fashion. So all I did was take all the coefficients here that were left and write it in this way. And we're going to continuously divide out x's from every single big polynomial that's left like this. So because we took out x minus 7/5, we can now just focus entirely on this polynomial, which is a little bit simpler than this one, and divide out more zeros from this, and then divide out more, and so on and so forth. So we know that 7/5 was a 0. We already took out 7/5, but we can take out negative 1/2 twice. So we're going to divide this polynomial by negative 1/2. So I need an empty piece of paper. So we have this polynomial up here. I'm going to write it up here. We have 20x to the 4th plus 20x3 minus 55x squared minus 60x minus 15. This is not f of x, it's just part of f of x. So we're going to divide this by negative 1/2. So we have our coefficients are going to be 20, 20, negative 55, negative 60, and negative 15. So we're going to bring down our first coefficient, which is 20. 20 times negative 1/2 is going to give us negative 10. 20 minus 10 is 10. 10 times negative 1/2 is negative 5. Negative 55 minus 5 is going to give us negative 60. We're going to take this number and multiply it by negative 1/2. We're going to get 30. Negative 60 plus 30 is going to give us negative 30. Negative 30 times negative 1/2 is positive 15. And negative 15 plus 15 is 0. So now we can, again, take out negative 1/2 one more time. I'm just going to continuously take out things. So we can rewrite this as, hold on, let me just rewrite, f of x is the same thing. So using what we had there, remember we had x minus 7/5, x minus 7/5 that we took out, and then we took out negative 1/2. So this is x plus 1/2. We change the signs when we factor it. And then we're left, so now we've taken out 1/1/2, we're left with this polynomial up here. This is going to be, we've taken out two x's, so it's going to start with x to the third. So this is 20x to the third plus 10x squared minus 60x minus 30. So this is another way to rewrite f of x. We've taken out two zeros now. We can take out -1/2 twice, so we're going to divide this polynomial using synthetic division by -1/2 again. So, doing the same thing, we're going to write the coefficients of this polynomial. We have 20, we have +10, we have -60, and we have -30. And we're dividing it by -1/2. Bringing down our 20. 20 times -1/2 is -10. This is going to give us 0. 0 times -1/2 is 0. -60 plus 0 is -60. -60 times -1/2 is +30. -30 plus 30 is 0. So we can actually rewrite f of x, just keeping track of what we've done so far, as x minus 7/5, x plus 1/2, and then we took out another x plus 1/2, times 20 x squared plus 0x minus 60. So this is one way, so we're rewriting this way. The only thing left to do is to factor out this last remaining portion. So I'm going to do that. So we have 20 x squared minus 60 is equal to 0. We can either plug this into the quadratic formula, or we can just solve it as it is. If we add 60 to both sides, we have 20x squared is equal to 60. Divide by 20 on both sides, we have x squared is equal to 60 divided by 20 is 30. No, it's 3, excuse me. And if we want to get rid of this square, we take a square root on both sides. Remember, when you take a square root, there's a plus minus. So we have x is equal to the plus minus square root of 3. So we know that f of x can be rewritten as, and this is in fully factored form, using what we've learned from the last portion, that f of x is the same thing as x minus 7/5, and then x plus 1/2 and x plus 1/2 are the same thing, so we can rewrite this as x plus 1/2 squared. And then we rewrote this portion. We found the zeros that this went into, so this is x plus square root of 3 and x minus square root of 3. So this is the fully factored form of f of x, and that means that our zeros are going to be positive 7/5 and a -1/2, and then plus minus square root of 3. This would be a negative square root of 3, this would be a positive square root of 3, if we equaled it into 0. So our zeros are x is equal to all of these numbers. And this is the fully factored form of f of x.